What's up everybody, my name is Blake and welcome to my YouTube channel, Everything Except Nothing. Today we're going to be doing a battery battle between the Streamlight Pro-Tac 1L-1AA versus the exact same flashlight, the Streamlight Pro-Tac 1L-1AA. Now this flashlight can use two different battery types. This one here we're going to be using the CR123 lithium 3-volt battery, and this one we're going to be using an alkaline AA battery at 1.5 volts. I want to see what the differences are and how well they work, so let's check it out. So first off, I want to show you, we have the CR123, which is fat and short, and then we have the alkaline AA battery, which is tall and skinny. Now, I'll show you how this fits in here and how the design works. It's actually really cool. If you put the CR123 in, it just sits in there flush, and the tail cap goes on just like a normal flashlight, right? But when you take this out and you put in the AA battery, it sticks out a bit. But Streamlight's done a really good job in designing this where you can actually push this down and the positive side is spring-loaded, and so that the battery goes in a little bit further and it fits the AA battery. So there's two parts to this battery battle, and the first part is I wanted to test light intensity and duration between the two different battery types. The second part of the test was a thermal test to see how hot the flashlights got to the touch, and took thermal readings at the bezel on both flashlights at incremental times throughout the test. Now, the CR123 got hot very quickly. It ramped up to 121 degrees at 25 minutes. And at that 25-minute mark, the alkaline AA only reached 83 degrees. So it took, the alkalines were ramping up really slow, whereas the CR123 went up very quickly. Now, over time, the CR123 started to gradually drop off after that 25 minutes, but the alkaline slowly ramped up. And at 118 minutes, the CR123 was at 78 degrees, and then the alkaline AAs reached a maximum temperature of 90 degrees. And at this point you can see that the CR123, although very intense at its 350 lumens at the beginning, has definitely dropped off, and the alkaline AA has a much more sustainable, lower lumen but consistent lighting for a longer duration. Pretty cool little flashlight. Because the CR123 hit 121 degrees so quickly, I was afraid that there was damage to the LED due to heat. Now, the temperature seemed to be distributed evenly across the frame, and I'm thinking that that's designed to do that so it pulls the heat away from the LED. But because I don't know how the heat sinks work in there, I was afraid that there would be diode failure. Now, what I did to test that was I let both flashlights cool, put fresh CR123s in both flashlights, downloaded an app to my phone that measures light in foot candles, and I measured both flashlights, and it was interesting because I found that the CR123 light that we tested actually had a higher foot candle than the one that we used in the alkaline portion of the test. So I don't think that there is any damage to this light due to heat because of the test, but time will only tell. We'll put both lights to the test for the next couple months, and I'll go ahead and post an update if there is any problem with the one that we used the CR123 in the test. I'm no lighting expert by any means or flashlight expert, but I thought it would be an interesting test to do. So if you guys have any questions or comments, please leave them in the comment section below. If you thought this test was interesting or insightful, please like and subscribe, and I will catch you guys on the next one.